In addition, it has a much smaller physical and ecological footprint than fossil fuels or most other renewable energies. We must make fast breeder nuclear fission work if we are to have energy for everyone. There is an urgency to start converting world energy supply to fast reactors because it will take decades to make the conversion. The point at which fossil fuels will no longer be abundant and affordable is uncertain, but appears to be approaching too quickly.
The economical recoverable reserves of uranium in the ground depends on its price. The energy in uranium is so concentrated that at $80 US per kilogram, its contribution to the cost of electricity is only 1.7 of a cent per kilowatt hour. If the price of uranium were to increase 100 times to $8,000 US per kilogram, the contribution to electricity price would be 17 cents per kilowatt hour. The North American range of electricity prices is 5 cents to 15 cents per kilowatt hour. The price range with uranium at a price of 8,000 US dollars per kilogram would be 22 to 32 cents per kilowatt hour, which would not be unmanageable. So the bulk of price paid by the consumer is the cost of the nuclear power plant itself. The advantage is that these costs are known and relatively fixed. With fast reactors, burning uranium even at the price of gold, the increase in electricity price delivered to the consumers is only 0.3 of a cent per kilowatt hour. Nuclear fission is the only source for generating electricity that can provide long-term stability of electricity prices, because more capacity can be added as needed. As natural gas and oil become scarce, people will be forced to convert to electricity for heating and cooking. It is essential that we have a good understanding of the long-term supply of uranium. The economically recoverable reserves of uranium in the ground are related to the price of uranium. The higher the price, the more that becomes economically viable. The supply also depends on using the 100 times more fuel-efficient fast reactors. The United States Geological Survey indicates that 3,192,000 tons of uranium are economically recoverable if the price is $80 US per kilogram. If the price were doubled to $160 US dollars per kilogram, then the USGS says that 10 times that amount would be economically available. There would be enough for 500 years based on providing all world energy by nuclear fission at about 6 times present world energy consumption. If the price of uranium increased by almost 100 times to the price of gold at 14,000 US dollars per kilogram, although gold is now closer to 20,000 US dollars per kilogram, vast quantities of uranium would become economically recoverable. Estimates of world energy for at least 50,000 years or more are not unreasonable when using fuel-efficient fast reactors. Thorium is also a nuclear fission fuel, and there is reported to be about 3 to 4 times more thorium than uranium. Nuclear fuel can also be manufactured using a fusion reactor. Safety issues always get resolved. There are many examples of this in automobile and aircraft safety, as well as in many other areas. Nuclear safety is under control. In addition to the atomic energy regulators of many countries, a section of the United Nations is dedicated to coordinating these procedures and ensuring they are followed worldwide. Procedures for security and safe handling of the many varieties of radioactive materials from thermal reactors are equally applicable to fast reactors. The incident at 3 Mile Island showed conclusively that with the proper design, the core of a reactor could be melted without release of radioactive materials to the area. Chernobyl was the result of unauthorized operation of the reactor. Operation of the reactor became dangerous, and the computer gave alarms to shut it down. The people operating the reactor silenced the alarms and continued towards disaster. The reactor was moderated with graphite, which caught fire, thereby spreading nuclear materials into the atmosphere. This reactor design has been modified. Most reactors today are moderated with water, and the few proposed with graphite moderators are of quite different design. Proliferation of nuclear materials is a concern and is manageable through the UN regulations. The two main problems encountered in converting the world to fast reactor nuclear fission energy are how to build fast reactors quickly enough and how to provide timely quantities of the fuel required for starting a fast reactor. They can be started on approximately 15% enriched uranium-235 or on plutonium. This shows how much nuclear electricity would be required in 2005 and 2020 if all electricity were from nuclear except for hydroelectricity. With current thermal reactors, we are about 1/4 of the way to supplying all electricity in 2005 by nuclear except hydro. Here's an estimate of when and how quickly fast reactors can be built and commissioned. The line is about the same slope as that of the increasing electricity demand. In other words, at the proposed rate of building and commissioning fast reactors, we are not closing the gap between carbon-free supply and demand. We must do much better than this to convert all electricity to nuclear without severe disruption of supply, as fossil fuels are depleted. If we are to avoid energy supply problems, there has to be an acute sense of the importance of nuclear fission energy to the world's people, and a sense of urgency about building and commissioning fast reactors.
The importance of energy cannot be overemphasized. There will be many necessary changes in our energy system, but there has to be enough energy. The warning signs are there now for oil and natural gas. It will take many years to get nuclear expanded to displace fossil fuels. It is urgent that we understand the situation now and begin to work in the right direction to avoid future energy supply problems. The sooner we start to close the gap shown on the previous slide, the better. We need to have a specific result for which to aim and a coherent plan of action that might achieve it. These are suggested on the next two slides.
The following are an appropriate set of results for which we should strive. It is clear that as humankind, we are looking for the following: to lift poor nations out of poverty. Each poor person must have access to more energy. Maintain the well-being of everyone. Income per person is directly proportional to energy consumption per person. Adapt to climate change. Without an adequate energy supply, it will be impossible to adapt to large or small negative effects in climate, regardless of cause. Protect the environment. This relies on the world having an adequate source of energy that has minimum impact on the environment. If such energy is not available, forests will disappear as people use them for fuel and the land is used to grow food. Standards for air, water, and food quality depend on energy and will slip when energy is in short supply. Protection of the environment includes reducing carbon dioxide emissions to the desired level. The following is a plan with a set of objectives that, if achieved, would give the desired results. We must all practice conservation in our own way. The result is to extend fossil fuel supply and give us more time to implement change to our energy supply. We must use energy as efficiently as possible, even though it may increase overall energy consumption. Increased energy efficiency may result in extending fossil fuel reserves to give us more time to implement change to our energy supply. Use renewable energies where they are effective. Together, renewable energies have a small but important role in world energy demand. We can start now towards producing all electricity by nuclear fission. Railroads can be electrified. Ships can be nuclear powered. Residential space heating and cooking and commercial space heating can all be provided by electricity. Our electricity generating and distribution systems must be made robust and have excess capacity. As fossil fuels become scarce, people will replace them with nuclear-generated electricity in non-transportation energy applications, such as space heating and cooking. We have all seen what happens to the grid during a heat wave, and millions of air conditioners are plugged in without anyone warning the utility. We must reserve liquid fuels for transportation purposes. This will extend our fossil fuel reserves until we develop the technology to power the transportation sector by nuclear energy in some form, possibly by manufacturing a liquid fuel of some sort. We must encourage the conversion of all large ships to nuclear power. We must use thermal reactors immediately because they are on the shelf. We must ultimately convert from thermal reactors to fast breeder reactors to use the energy remaining in spent fuel, to minimize nuclear waste, and to have adequate energy for thousands of years.
It is clear that providing future energy supply is a much more important problem to solve than climate change. That is not to say climate change is unimportant, but without adequate energy, it will not be possible to adapt to negative effects of significant climate change. There are no perfect substitutes for fossil fuels. Because nuclear fission fuel is available on a large enough scale, nuclear fission energy is much closer than any other alternative to replacing fossil fuels. Further, nuclear energy capacity can be expanded as needed to match the rate at which energy is used. Finding an alternative to oil as road and air transportation fuel is not going to be easy and will take a long time. In the meantime, we must reserve oil, coal, tar sands, etc., to provide liquid fuels for road and air transport. It will require much time and effort to find an alternate energy for road and air transport. Now that we know the objectives that have to be achieved to give the desired result, we can make more appropriate decisions along the way towards it. For example, converting all fossil fuel electricity generation to nuclear would reduce Canada's carbon dioxide emissions by about 1/5, and those of the United States by about 1/3. Ultimately, all electricity must be generated by nuclear, so there's a good incentive to start right now. Nuclear fission is the new coal and the path to the world's energy future.
Mr. Lightfoot has presented an objective, science-based picture of the world energy situation. It points out the importance of fossil fuels to the well-being of everyone, the importance of having enough energy to replace them, and the solution available to us. It is not a doomsday scenario, but does not deny the difficulties that will be faced in achieving a solution. It is the culmination of many years of research which began officially in 1992. The presentation itself has gone through many iterations since the first one in February of 2000. A technical paper of an earlier version is also available. Mr. Lightfoot is a retired mechanical engineer and is completely independent. He is a member of the Global Environmental and Climate Change Center of McGill University and has been associated there since 1992. Many of these slides and the description of these slides, including references, are on the website. The complete text with references is on the DVD-ROM portion of this disc.